Hello everyone, this is Abhishek Mahanti and you are watching Padat Vigyan. So students, in this video I will solve a HOTS question and the question is from the chapter Electric Charge and Field. So let's get started. So look at the question. The question is a particle having a charge that of an electron and mass 1.6 into 10 to the power minus 30 kg is projected with an initial speed u at an angle of 45 degree to the horizontal from the lower plate of a parallel plate capacitor as shown in the figure. The plates are sufficiently long and they have a separation of 2 centimeter. So you have to find the maximum value of the velocity of the particle so that it does not hit the upper plate. Take the electric field between the plates as the 10 to the power 3 volt per meter directed in the upward direction. So look at the diagram here. We have a parallel plate capacitor and we'll discuss about capacitor in chapter 2. But remember that in a parallel plate capacitor we have two plates which are parallel to each other, and one plate is positively charged, the other plate is negatively charged. So in this diagram we have these two plates and it is given that electric field is upward. The magnitude of electric field is 10 to the power 3 volt per meter, and we know that electric field is directed from positive to the negative charge body. It means the lower plate must be positively charged and the upper plate must be negatively charged, so that the electric field is directed upward. So I will give the charge to this plate. Upper plate is negatively charged and the lower plate is positively charged, and it is given that we have a charge particle whose charge is same as the charge of electron. So I'll write the magnitude of the charge only, that is 1.6 into 10 to the power minus 19 coulomb, because you know that the charge of electron has this much magnitude and it is a negative charge. So in the question we have a negative charge having value this much, 1.6 into 10 to the power minus 19 coulomb, but I have written only the magnitude. And the electric field is how much? Electric field is 10 to the power 3 volt per meter, and it is given that the mass of the charged particle is 1.6 into 10 to the power minus 30 kg. This is the mass of the charged particle, and the charged particle is projected from the lower plate from this point with some initial speed u. The initial speed is equal to u, and or you can say that initial velocity u, which makes an angle 45 degree with the horizontal direction, means this angle is 45 degree, and the separation between the two plates is 2 centimeter. So we have to find what is the maximum value of this speed u such that the charged particle does not hit the upper plate. So students, remember that in class 11 we had discussed about the projectile motion. Uh, I will remind you a few formulas. Suppose this is the horizontal direction and from this point I will project a body with some initial velocity u, making an angle theta with the horizontal. Then we know that under the effect of gravity the body will describe a parabolic path like this, and it will fall on the ground at this point. From point A you have projected the body, and at the point B it will hit the ground, and this is known as the maximum height, hm. The component of velocity along the horizontal direction is u cos theta, and along the vertical direction is u sin theta, and we know that in this case the gravity is also downward, g is downward. But in this problem we will ignore gravity because the charge has very less mass, so we can ignore the gravity here, and here we only consider the electric force acting on the charged particle. So students, we know that a negative charged particle experiences force opposite to the electric field. So tell me, what will be the magnitude of force acting on the charged particle? The magnitude of force will be F equal to Q into E, and the acceleration of the charged particle will be force by mass, that will be equal to QE by M. Is that clear? And the acceleration will be downward because we have a negative charge particle. It means the negative charge particle will experience force in the opposite direction of electric field. Since electric field is upward, so the electric force will be downward, and hence the acceleration will also be downward. So in this kind of projectile, we know that the maximum height hm is given by this formula u square sine square theta by 2g. But in this problem we will replace g with a, because we can ignore gravity and we have to consider the acceleration produced due to the electric field. A is equal to how much? A equal to q e by m. So q is the charge of electron, 1.6 into 10 to the power minus 19 coulomb, into electric field is 10 to the power 3 volt per meter, divided by mass of the charged particle is 1.6 into 10 to the power minus 30 kg. So here 1.6 and 1.6 will cancel, you'll get 10 to the power minus 19 into 10 to the power plus 3, and now this term 10 to the power minus 30 will go to the numerator, it becomes 10 to the power plus 30. So the answer will be 10 to the power 14, 10 to the power 14 meter per second square. So this is the acceleration produced due to the electric field, and you can see that this acceleration is very large as compared to small g. That's why we can ignore the effect of gravity here. So now it is given that the separation between the two plates, look at the diagram here, the separation between the two plates is 2 centimeter. So the charged particle will follow a path like this, and it will land on the lower plate at this point, and this is the maximum height. So this maximum height is equal to the separation between the two plates, which is 2 centimeter. So in the question it is given that the charged particle should not strike the upper plate. It means the maximum height should not be 2 centimeter or more than that, means the maximum height should be slightly less than 2 centimeter. So in limiting case we can put the maximum height hm equal to 2 centimeter, means hm will be either equal to 2 centimeter or less than 2 centimeter, that is equal to 2 into 10 to the power minus 2 meter, but hm cannot be greater than 2 centimeter. So in this formula hm equal to u square sine square theta by 2g, just replace g with a. I'll write a here. That implies hm is 2 into 10 to the power minus 2 meter, that is equal to u square, and sine square theta means theta is 45 degrees, so it is sine square 45 divided by 2 into a is 10 to the power 14. So students, we know that sine 45 is 1 by root 2. So sine square 45 will be 1 by root 2 whole square. So I'll write 2 into 10 to the power minus 2 equal to u square. Sine 45 is 1 by root 2. So 1 by root 2 square means 1 by 2 divided by 2 into 10 to the power 4. That implies 2 into 10 to the power minus 2 equal to u square into 1 by 2 divided by 2 into 10 to the power 4. That implies u square equal to, bring all these terms to left side, you'll get 8 into 10 to the power how much it will be 2, 8 into 10 to the power, so this is 14, this is 14, so it will be how much, this is 14, sorry, okay, so it will be 10 to the power minus 2 plus 14 means 10 to the power 12. So u equal to square root of this quantity 8 into 10 to the power 12, so that will be equal to 2 root 2 into 10 to the power 6 meter per second. It means the maximum speed with which the body or the charged particle can be projected is 2 root 2 into 10 to the power 6 meter per second. It means we have to project the charged particle with a velocity slightly less than this value. So students, in this way you can solve this question. Hopefully you have understood the process, and I will come with some more new questions in the upcoming classes. Till then, have a nice day and bye.